Welcome back to trigonometry. Today I'm going to start explaining and defining some of the basic trigonometric functions that you're going to have to know very well. And these functions are absolutely fabulous in physics. They show up in many, many useful places, and I hope you'll enjoy them. First, you will recognize your basic coordinate grid, the x and y axis, which I've drawn here, slightly awkward and crooked. However, remember some things about this, and maybe I'll put a, so here's your Cartesian coordinates, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. X-axis, incidentally, this is the line y equals 0. Here is the y-axis. This is the line x equals 0. This is the first quadrant, second quadrant, third quadrant, and fourth quadrant. And the reason I'm putting this up here is everybody, of course, just went through algebra and knows these things, but we're going to start using this. What I've done is I've drawn this right triangle in here in the first quadrant, and I'm going to start explaining the trigonometric functions from here. And what I have is some angle alpha. So this angle, I suppose I'll stay in red. Alpha in radians. And correspondingly, this distance up here is y, and this distance down here is x. And now what I'm going to do is define these functions in the most generic kind of way, and it is absolutely the case that you need to memorize this and know this. Sine alpha is defined to be r divided by y, or y divided by r, I'm sorry. And incidentally, what is r? We're using r for radius. You would usually call this h as a hypotenuse. What do we know from Pythagorean theorem? We know that x squared plus y squared is equal to r squared. This is Pythagorean theorem. We have a right triangle. But in trig, I'm going to tend to make this r because this is going to end up being the unit circle, and that's going to represent the radius. But you usually have seen this as an h hypotenuse. So the sine of this angle alpha is given to us by y divided by r. The cosine of this angle alpha is given to us by x divided by r. The tangent of this angle alpha is given to us by y divided by x. And incidentally, that's because tangent is defined as this. Tangent alpha is sine alpha over cosine alpha. Sine alpha, once again, was y divided by r. That's a pretty fancy y. Cosine alpha is x divided by r. Hopefully everybody remembers when you divide by a fraction, it's the same as multiplying by the reciprocal. This is y divided by r times r divided by x. This is y divided by x. And once again, this is where these things make sense. Number one, the first thing is we always have to be worried about dividing by 0, which I'm actually going to explain in some detail because I don't think people do enough. Can the radius ever be 0? Can the radius of a circle ever be 0? The answer is yes, but it is when the circle is only a point, and it's called a degenerate circle. And to the best of my knowledge, that's not going to show up in this course. So the radius is always going to be a positive quantity, greater than 0. So we do this. We do have some problems, though, depending on what our angle alpha is. And let's take, well, so the first thing is what's going to happen to, you'll notice as this angle gets steeper, like this, so I'm just going to change this. What happens as the angle gets steeper, x is coming back into 0. As this angle, as alpha goes to pi over 2 radians, which is 90 degrees, but it's really good that you start thinking about in radians, what's going to happen, this x is going to be going to 0. So tangent alpha is going to have a lot of problems at when alpha goes to pi over 2 or 90 degrees. As a matter of fact, it's going to blow up to infinity. And we are going to keep these into about 9-minute sections, and I think, are we getting close? 5? Okay, so we're going to go a little more here. I didn't look at the clock when we started. Let me briefly go into a few more of these trigonometric functions and how they're defined. All of these are absolutely going to have to be memorized, and you're going to use them soon and quite often. So tangent of alpha is y over x. The first trigonometric identity that you want to know is that for any alpha, let's see, for any alpha, and this is in radians, sine squared alpha plus cosine squared alpha equals 1. This is an extremely handy identity, and I want to show you why. I typically ask students to prove this on their first tests. It's hard to say. This is being made as a lecture series. I may not be your instructor at some point. This could be used by somebody else, so I don't know that they'll ask you this. However, this is a good thing to know. Why is this true? Well, sine alpha squared is going to be this, y over r squared. Cosine alpha squared is going to be this, x over r squared. This ends up being y squared over r squared plus x squared over r squared. We have the same denominator, so this is y squared plus x squared over r squared. But remember the picture that this came from, where these are being constructed. Here's y, here's x, here's r. This is a right angle. We know that x squared plus y squared equals r squared. So y squared plus x squared equals r squared. So this is r squared over r squared. This is equal to 1. This is called an identity because for any alpha it's true, any alpha at all in radians. And it is absolutely the first and most fabulous thing for you to memorize. And I bet now it's about 9 minutes. We got 2 minutes left? Okay, so I'm not counting too good today. I'll tell you a little more then. Because this is true, think of what we can happen. This means subtracting sine squared from both sides. We have cosine squared alpha is equal to 1 minus sine squared alpha. And similarly, we have sine squared alpha equals 1 minus cosine squared alpha. These things are just going to start showing up a lot. When you see cosine squared alpha, it may be the case that you need to think of this in terms of 1 minus sine squared. It just depends what it's going to be. But for the first part of this, what you really need to understand is where this picture is coming from. Here's your generic right triangle. This is some angle alpha. This is some height y. Here is some length x. Here is the radius, which, like I said, we're eventually going to be thinking of this as a part of a circle. And we have r squared equals x squared plus y squared. Okay, so we'll move on to the next one.